Guys, today we are going to be doing the actual 11-2 lesson and notes, which is using the exponent rules that we covered earlier in the week, along with our Zoom on Tuesday, but having rational exponents, which means that they're going to be fractions. So when you have the product rule, you're going to be adding the exponents, but your exponents are going to be fractions. When you have the power rule, you're going to multiply your exponents, but they're going to be fractions. The quotient rule means you're going to be subtracting the exponents, but these are going to be fractions. So I think you get the point that today we're concentrating all on the exponent rules, but with fractions. So I did start going over the notes in the Zoom on Tuesday, and so I'm just going to go through the notes that we started in the Zoom. I don't have an extra copy, so I'm going to go through these by hand with you guys, along with a couple extra questions for you this morning. So the first rule that we're going to talk about is called the product rule. And the product rule means that we have the same base, so in this case our base would be a. Let me change that to an a, and the exponents are m and n. So when you have the product rule, you're going to add the exponents together. So I'm going to add m and n. Okay, base stays the same. We don't change the base whatsoever. So then I'm going to go across and do number 7, because number 7 is the example for that particular rule. So again, this is the product rule. So in this question, we have 3 to the 1/2 power times 3 to the 3/2 power. And so they have the same base. I don't touch the base. I just add the exponents. And when I add 1/2 and 3/2, I get 4/2. And 4/2 is otherwise known as 3 squared. 4 divided by 2 is 2. 3 squared is an answer of 9. Some of you guys left it like this, but when it says simplify, so again the directions say simplify the expression, that means that you have to get a numerical answer. So that is product rule. Product rule means they have the same base, and you are going to add the exponent. It's just going to be all fractions. Question number 2 is the power rule. So the power of m is being raised to the power of n. And so when that's the case, then you're just going to multiply your exponents. Leave the base the same and just multiply the exponents. So again, the question that goes with that is number 8. And number 8 has a base of 4, a power of 3/2, and it's being raised to the second power. And I'm going to put that 2 over 1 because when you multiply the exponents, then you just multiply straight across. So then I'm going to multiply 3 times 2 and 2 times 1. So this is going to be 4 to the 6/2, which is 4 to the 3rd power, and then 4 to the 3rd power is 64. Now during the Zoom I did say to you guys that you could cross cancel like we had done back in the day. Before all of this started, we had been canceling things quite a bit. So you can cancel the 2's, and then you'd have 3 over 1, and 3 over 1 is 64. So same answer, just different way of doing it. Question number 3 is a mixture of the product rule and the power rule. It's kind of two of them going on at one time. So you, in parentheses, have two things. So again, that could be a number, could be a variable, could be a number and a variable, and you just raise both of these to that exponent. They're not going to be the same base. So number variable could be something like 2x raised to the 2nd power, and you'd have to do 2 to the 2nd power and x to the 2nd power, which would be 4x squared. So then in the example that matches that would be number 9. Number 9 is 9 times 4. Generally speaking, you don't have two numbers raised to the exponent, but in this case it is. So usually it's like a 9x squared. So then you're going to do 9 squared. Oh, that's a 1/2 power, sorry. 9 to the 1/2 power times 4 to the 1/2 power. And some of you guys in the last assignment wrote that as 4.5. It's not saying half of 9, it's saying square root of 9. So square root of 9 times square root of 4. Square root of 9 is 3, square root of 4 is 2, 3 times 2 is 6. Now you could, but in using this rule you're not supposed to, 9 times 4 is 36. And 36 to the 1/2 power means a square root of 36. And the square root of 36 would be 6. So you could do it that way as well, even though that rule, not really asking you to do that, but still come out with the same answer. Question number 4 is the negative exponent rule. When you raise it to the negative exponent, it is creating the reciprocal. Cross the line, change the sign. And my pen's about to run out here. So when you cross the line, it means it's going to the reciprocal relationship. So from the numerator to the denominator. So numerator to the denominator means that my a is still the same base, but my m is now going to become a positive. So this is negative exponents. Cross the line. That means it's going from numerator to denominator. Change the sign. Means that it's going from a negative exponent to a positive exponent. And this is your answer. You know, in that case, there's nothing to simplify. So cross the line, change the sign. That's with your negative exponent. Or you could say reciprocal. Okay, the example that goes with that, number 10, is 25 to the negative 1/2 power. So 25 is your base, 1/2 is your exponent. I'm going to cross the line, so it's going down here. Change the sign of the exponent from a negative to a positive, and that's just under 1, because these just cross the line, change the sign. 25 to the 1/2 power means square root of 25. And the square root of 25 is 5, so your answer is 1/5. Again, you do not want to use calculator. If anything, you want to use the resource sheet that I gave you that has all of the exponents on there. So if you're reading this, it would be 25, and then the square root of 25 is 5. So use this sheet, don't use a calculator. Alright, question number 5 is the quotient rule. Quotient rule means that you have the same base. And my black pen is done. Quotient rule means that you have the same base with different exponents. So for number 5, my base is a, the exponent is m over a to the nth. So same base, do not cancel. You're going to subtract the exponents. Do not cancel. So you're just leaving the base the same. Subtract your exponents. And that will be your simplified answer, possibly, if you don't have to do any other particular math to that. The example that goes with that is number 11. Number 11 is 6 to the 5/2 power over 6 to the 1/2 power. Again, keep your 6's the same. You're not canceling the 6's. What you're going to be doing is subtracting the exponents. See if I can squeeze this in here. So 5/2 minus 1/2. Do not cancel the 6. 5/2 minus 1/2 is 4/2. 4/2 is otherwise known as 6 squared, and 6 squared has to be simplified because it can to 36. Okay? Do not cancel the bases. Subtract exponents, leave the same base. And the last of them all, last but not least, of course, this is kind of like your quotient rule mixed in with your power rule. In other words, you have a fraction. So we have a fraction raised to an exponent. So you're just going to raise the numerator to the exponent, denominator to the exponent. So numerator, denominator, raised to the exponent. Okay, the example that goes with that is 8/27 to the 1/3 power. And again, this kind of came up last week or in the beginning of the week on one of your assignments. So you're going to take the numerator to the 1/3 power, denominator to the 1/3 power, but the 1/3 power actually means cube root. So cube root of 8 over cube root of 27. And you just leave it as a fraction. It's going to come out to a very nice fraction. Cube root of 8 is 2. Cube root of 27 is 3, so 2/3. So that's a very, very nice fractional answer. Okay, now on the bottom, actually on the back, I gave all of the exponent rules again on the note sheet, and I also included some additional examples. So you're going to see the product rule again, quotient rule, plus some examples. So now I'm going to go to example 1. This is part A and part B. Okay, the directions say simplify the expression. Assume that all variables are positive. Exponents in simplified form should be positive. So again, they have the same base. This is the product rule. So because they have the same base, I'm just going to add the exponents. So I'm going to add, keep the base, 3/5 and 7/5. 3/5 and 7/5 make 10/5. And 10/5 reduced down is squared. And then 25 squared, I don't know that I went that high down on your list. 25 squared is 625. Okay, letter B is the quotient rule. Quotient rule means keep the base, subtract your exponent. So 3/1/3 minus 2/3. And this base should be an 8. Okay, so 1/3 minus 2/3 would be -1/3. So quotient rule means subtract, keep the base. This is now a negative exponent. Negative exponents, you're going to cross the line, change the sign. So this is going to come to the denominator. Change the sign from a negative to a positive. And then the 1/3 power means cube root. Cube root of 8 is 2. So this answer would be 1/2. Okay, then I left a couple examples with you guys to try, and I will check back in with you Friday to give you those answers from the on your own second part of this lesson. So that concludes our using fractional exponent lesson.